In statistical analysis, correlation is a vital parameter that predicts the degree of relationship between two variables. The two variables may increase or decrease simultaneously, or move inversely with respect to each other. Further, they may be going forward independent of each other. All these relative moves can be very well analyzed using the correlation analysis. Let's understand the correlation by some data. Consider the table here, having weights of 5 students along with their heights. It can be observed that as the weight is increasing, height is also increasing, or vice versa. This is true as well. In normal course of life, higher the height, higher is the weight. Therefore, it can be stated that there is a high degree of correlation between height and weight. In another example, a table is presented here that shows the number of study hours and percentage of marks. It can be observed that higher are the study hours, higher is the percentage of marks, and lower the study hours, lower the percentage of marks. This is very common theory. Again, therefore, it can be stated that there is a high degree of correlation between study hours and the percentage of marks. Now, let us put all variables in a single table, that means weight, height, study hours, and percentage of marks. As the weight increases, height also increases. Or vice versa. Therefore, weight and height can be correlated, as both weight and height increases in same direction, hence it's a positive correlation. Same way, in case of study hours and percentage of marks, as the study hours decreases, percentage of marks also decreases. Hence here also, a positive correlation is observed. Hence in both cases, there is a positive correlation. Now, let us try to find the degree of correlation between height and study hours. Note here that, while seeking correlation between two variables, one variable should be in either ascending or descending order. Here, the height is in ascending order. Now, we can see the movement of study hours with respect to height. Clearly, there is no simultaneous movement of study hours either in positive or negative with respect to height. Hence, there is no correlation between height and study hours. And this is logical as well. Similarly, if we try to find a correlation between height and percentage of marks, then also, it can be observed that, as the height increases, percentage of marks does not show any continuous positive or negative trend with respect to height. Hence, there is no correlation between height and percentage of marks. This is logical as well. Percentage of marks should not depend upon the height, but upon study hours. Same case with weight and study hours also. If weight increases, it cannot be guaranteed that study hours will also increase. Hence, no correlation between weight and study hours. That is logical too. Same way, no correlation between weight and percentage of marks. Percentage of marks should be correlated with study hours only. Now, let us talk about the positive and negative correlation. As the name suggests, in case of positive correlation, both variables move in the same direction. And, the output can be predicted using the linear equation formula as given here. The maximum positive correlation can be equal to 1. However, in case of negative correlation, the two variables move in opposite direction with respect to each other. The output can be predicted using the linear equation again, but, with negative slope. The maximum negative correlation value is -1 here. When, the two variables do not show any dependency on each other, then, it's a no correlation case. In that case, the correlation approaches towards 0, or, very poor correlation. In this case, the output cannot be predicted, as both variables seem to be independent of each other. Now, let us understand the correlation by its mathematics. The mathematical formula for correlation is given here. Here, x bar is the mean of x. Y bar is the mean of y. Xi is any data in x, yi is any data in y, and n is the number of data elements. Now, let us take the correlation by example. In the table, consider one variable as x, and the other variable as y. Get the mean of x and the mean of y. Compute the difference between x and mean of x. Similarly, the difference between y and mean of y. Now, compute the product of differences of x and y with their mean respectively, as presented in the table. Further now, compute square of difference of x with its mean, and square of y with its mean. Get the sum of x minus x bar and y minus y bar. Get the sum of square of difference, that is, square of x minus x bar, and square of y minus y bar. Apply the correlation formula, put all the respective values in the correlation formula. And, finally calculate the correlation between x and y. A Python code using data frames is given here to calculate the correlation between x and y. The correlation output is presented as 2 by 2 correlation matrix. The top left value in the matrix is correlation of x with x itself. Hence, a maximum value of 1 is obtained. Same way, in the bottom right cell, the correlation of y with itself is obtained. And so as 1 is given here. Now, here correlation value between x and y is given here. And same way, correlation value of y with x is given here. Note here that, the correlation between x and y, or y and x, it is the same thing. Here are few of the frequently asked questions on correlation in interviews.